from the Universitas Samratulangi, Manado. It is, this is the title of my presentation. After we learn from the very difficult field in crack theory and also the material of material science from the Malaysia, then I would like to show you about the EC's field of research. So this is a combination between how to develop a computer sensor and then to develop application in medical devices, especially for using artificial intelligence. I am a physicist actually, but today I would like to talk about the instrumentation, I think, sensor-based instrumentation. And I come from Kajama in Yogyakarta. Okay. This is the outline. I think I will start from the biomarker of the breath for medical detection, and also I will continue with the QCM-based gas sensor development characteristic, and then continue with the sensor array combined with artificial intelligence in the past, especially for copy detection, and then the future work of our similar device but for detecting another disease. Okay, this is a big problem in developing a gas sensor actually. This is related to the high selectivity or low selectivity. If we develop the high selectivity of the sensor, it means that we can use the single sensor for quantitative measurement for the single molecule. But actually it's very difficult. Very difficult. Why? Because a lot of molecules, and it is impossible for us to detect one by one with a pair of very selectivity sensors. That's why many researchers then develop low selectivity of the sensors. That's why by using the non-selectivity sensors, that we have the array of the sensor to make a qualitative analysis, qualitative measurement. It will be combined with the artificial intelligence, and it is possible for us to develop such instrument for medical devices, for example. And as we know that the most commercial product of gas sensor, or even in development in some laboratory, is global selectivity or low selectivity of sensors. And then, okay, I start from these papers. And we can develop the sensors with high selectivity. For example, in my current research, how to detect ammonia. Then we can use the sensor for detecting the kidney disease, for example. We can develop sensor for acetone that measure from the exhaled breath. Then we can use the sensor for detecting, for example, diabetes, and etc. So it is a challenge of developing sensors. Then I start from our review papers related to the basic mechanism of the sensor based on quartz crystal microbalance. Attempt to develop sensor with high selectivity, especially for the what we call ammonia gas sensors. So this is very easy to understand. If we have a pair of crystal of quartz crystals, then we can put something. Polymer, for example, then it is vibrate with high fabrication, and then we can catch the specific gas on the surface of the sensor. So this one is typical of the response of the sensors. So it's very easy to understand. And the correlation is if a lot of gases, molecule, attract to the surface of the sensor, then the frequency of the sensor will be reduced from the original ones. So this is some illustration how to develop sensors. When you visit my lab, most of instrument for developing for producing nanofiber is developed by ourselves. It is not commercial one. And we want to measure the characteristic of the sensor. We also develop the measurement system. Of course, it should be standardized before using for detecting, characterizing the sensors. And a lot of mechanism of the sensors, interaction between, for example, ammonia sensing. And I illustrated in this presentation. This is for ammonia sensing. This one is formaldehyde sensing, and then the alcohol sensing, and etc. The mechanism actually is similar, but we should understand what material that can be used for active material of the sensors. Okay. And this time we publish in the journals when we start to research or develop the gas sensor of ammonia, then the sensitivity is still very low. Still very low. But then we continue with another techniques how to improve the sensitivity and also the selectivity of the sensor by using the molecular imprinted polymer. In this case, the polymer we use is a polyvinyl acetate and chopped with another material, in this case a boric acid. And we have improvement, high improvement from 0.07 to 0.24 hertz per ppm. So the increase of the sensor performance is significant. And then we improve more. We publish this paper in this year. Yeah, a lot of effort to be used for development of such sensors, and the focus one is how to make the surface area of the surface of the sensor to be bigger and bigger. The bigger surface area volume will be result in high performance of the sensor. I mean, the sensitivity of the sensor will be improved. And then, actually, we also possible to have another technique how to improve the not only sensitivity but also limit of detection. Because when we are able to detect ammonia from the exhaled breath samples with a very low limit of detection, that we can use the sensor for detection of kidney disease, for example. When we are able to develop the sensor with the detection of the breath sample containing the very low concentration of acetone, then we can use the sensor for detecting diabetes. That's very easy. And this year also we October 2023. This is the most the newest of our paper published at this moment. We published how to improve the sensitivity, selectivity, and also about the sensor response and also recovery time. It's also important another parameter of the sensor. Not only sensitivity, not only specificity, but also in the what we call the fast response, fast recovery is also very important. Okay, now we improve significantly also using the kind of the sensors. We hear that this is a sensor with high selectivity to to ammonia, and the sensor there's low sensitivity to another gases. It means that we can also improve the sensitivity very high, 2.95 hertz per meter is very high, and it will be used for medical detection. We realized after we produce many sensors, but the selectivity is a big problem, then we can try to make the non-selectivity sensor with different material to be electronic noise. So the electronic noise is consisting of more than one sensor combined with the feature extractions and also the pattern recognition system, even in artificial intelligence or machine learning, then we can develop or we can use this kind of device not for quantitative detection, but it is for qualitative detection. Means that this device can recognize, can classify, can differentiate between sample and another samples. For example, in this case, we can by using the same techniques, we can differentiate between different cases. So it is possible. And yeah, this is another application of artificial intelligence, I think. We can produce some insight of prediction, what material, what cases that can be correlated for high performance of the sensor. So we use to create the prediction model, the chemometric techniques involving the machine learning algorithm. We can understand how to make the sensor to be high performance. Before using this technique, before using the machine learning, we try to trial and error, and takes time. It's very cost. So by using the machine learning, then we have very short time to develop the sensor to be high performance sensors. This is another result of our prediction, what material and what cases that can be detected, that can be concluded in our papers. Okay, the next I want to show you about the utilizing the sensor array with the global selectivity for electronic noise. The electronics like our nose that can detect many objects. Okay, that can detect the object by first training and then testing. This is similar. And then during COVID-19 pandemic, we realized that the gas from our exhale breath is still not single one. It is a very complex gases. Yeah. So it is impossible to detect COVID-19 just only using one sensor. So we use many sensors that we call electronic noise. Okay, this is an example of our production during the COVID-19. We produced more than 5,000 machines during the COVID-19. We calculate more than 300 billion rupiah, yeah, for this time. Can you click this? And this is a photo. This is part. This part. Yeah. Okay. This is an example of our process in downstreaming the message. No sound. Yeah. Without sound. we can try to move faster. This is just illustration. This is a condition when our governor and right now to be the president of Indonesia coming to our lab and try to use the machine, then buy directly. Almost 100 machine at this time. So from this, I have money to produce more and more machines. So it is our experience at this time. This is Kanjar Pranowo unit. I think also famous here. Okay. Okay, stop. Then come back to my presentation. Okay, thank you very much. This is our papers related to electronic noise for COVID detections. We published in high index, high impact factors, more than 15 after this. So publication is also important for us, even we develop instrument. So just making instrument is possible to publish, but then you use the instrument to measure something, then we can publish. We use of course it is not, they are not a good sensor because the sensor is not selectivity. And then a lot of the problem in the system, in the environment, but we still have accuracy of more than 95% at this moment. And then we publish also another papers related to the COVID-19 detections, and we have we dealing with not only 2 devices, we combine with 1,000 devices. So a lot of data from many places, in the train station, in the airport, in the hospital, in the university. When we collect, then we train. So a lot of variation of the data, then we collect, then we still have accuracy of more than 95%. Of course, then the accuracy decreased, but it is still reasonable. Okay, this one is, right now we use our genus C19 not for detecting the COVID-19, but for detecting the neonatal sepsis. Neonatal is like infection of the baby. The sample for detection is from feces, so it is totally non-invasive one. Hopefully, we will have another AI that can be injected to this machine, the same machine, but we will inject it in the machine, and this machine can be used for detecting the neonatal sepsis. And another one, at this moment, we also providing tests in the hospital that we use the same machine, but for detecting the pneumonia or infection in our lungs for child. Yeah, in summary, the development of high selectivity sensor is not easy. So, in the market mostly available for less selectivity, this type of sensor is used to measure the gas concentration quantitatively, of course. But for the gas sensor with the global selectivity or low selectivity, we still use this, a very powerful used in sensor information. And here, another gas sensor combined with artificial intelligence algorithm, it's called the electronic noise, whose function is to recognize, classify, prediction, and like our human. I think this is all my presentation, and I invite young lecturer from the Universitas Samratulangi to join us to do some research with a very not expensive, I think. Yeah, because most of the machine is developed in laboratory. Thank you very much for your kind attention.
Thank you very much, Dr. Wadriana. Are there any questions from participants? or